Thank you, Ian. Thank you for giving me the chance to talk about the freshwater key biodiversity areas in the Mediterranean Basin hotspot. We made in the last years quite some efforts to identify KBAs within the Mediterranean biodiversity hotspot. So basically, I don't need to say much about this. This was all the work was done geographically for the scale on the hydro basins, as this was presented today, including all the discussions if this is useful or not, and so on. So we overlaid on the first step the distribution ranges of threatened freshwater fishes, threatened freshwater mollusks, dragon and damselflies, and aquatic plants. But we should understand that most of the data come from fishes and mollusks, because these are the most threatened groups, so they have a high number of threatened species, while plants and odonates, they have very few threatened species, so they don't make a difference. So you see there's different shading in the whole story, how many trigger species occur together. And then we had validation workshops which really made a difference. This is a picture from our North African validation workshop, but we also had a validation workshop on the Balkans. So this area, and on the Eastern Mediterranean, so this area. We had no validation workshop because we had no money for Spain, southern France, and Italy, so you don't see then validated KBAs here. So the validation workshop is really a terrible job, because you go through the fact sheets which are here on this BirdLife data zone. You can easily find them. And with the experts, we go through all the potential KBAs. We check all the species lists. We check, is there protected areas, what's going on, how is the status of the area, do the species really occur there, or is there other species or elements in freshwater biodiversity not covered by these threatened species maps. You remember from the other presentation by you, I guess, that there's other criteria to identify KBA. So we go through all of this. And by this, you see, we can restrict this big map, you remember, look like this, to quite a limited number of sites, which then really make a difference for priority setting. So we validated 167 freshwater KBAs within the Mediterranean biodiversity hotspot. 491 trigger species, 377 threatened, and so on and so on. Also 40 of these sites meet the criteria as ACE sites, so really spots which we, if we would lose them, then full species would go to extinction. 75% of the total area of these KBAs are outside protected areas or any pre-existing protected areas of other KBAs. So basically they are unprotected. If this matters or not, we don't know. Thank you.
Do you want to just like two minute just announcement about comparable work?
You want to go super fast, mine is super fast. Because it's 2 minutes.
So thanks to Peng Yin York, my life is simpler. This is the results of a freshwater KBA project that we recently completed in the Western Ghats hotspot in Southern Asia. The area is exceptionally rich in freshwater taxa. We've got endemism from 95% in freshwater crabs to 60% freshwater fish. and 16% of freshwater taxa are threatened. So following up on the IUCN freshwater assessments, we carried out a project looking at identifying key biodiversity areas in the region. Yeah, so we've, because of lack of funding, we focused only on 2 of the most diverse regions within the Western Ghats hotspot. So, yeah, the 2 states of Kerala and Tamil Nadu. So we've identified 34 freshwater KBAs, which have been triggered by 235 KBA trigger species, most of which, as you always said, is freshwater fish. So there's a lot of data available on freshwater fish. Also, odonates, shrimps, and crabs. Yes. Also, 10 of the freshwater KBAs that we've identified are contain one or more of AZE species. So this is following up on the discussion of whether protected areas are actually good or bad. So this is an example of a national park which has been triggered by 36 species, and it also has the highest number of AZE species. We've got 3 freshwater fish, particularly endangered freshwater fish, that are restricted to the single site. But in spite of this being a protected area, there's huge amount of stocking of invasive species, pollution from tourism, and so lots of interventions going on inside this protected area. So as a follow-up, we are trying to set up India's first freshwater AZE site inside this protected area. That we are working with the local government, which is being appreciated by both the local and central government. We're also trying to complete the KBA prioritization for the entire Western Ghats hotspot, just not 2 states. So again, the funding is staying there. And we've got, we do a lot of education and outreach campaigns with all interested stakeholders. How best we can use KBS here. Yeah, thank you. Yes, yes. So there's a larger presentation on the same topic tomorrow in the afternoon. Yes, yes, 10:30 in the morning. So if somebody's interested, please.
Yeah, well, I really would encourage you to go to these follow-ups because they're obviously closely linked. So, you're up.
I'm wearing 2 hats here. One is as a scientist in the Office of Environment and Heritage. We manage 860 national parks across New South Wales, of which Sydney is the capital. We manage the environmental water and we manage certain species. My other hat is Geobon, and Geobon is a global community practice with a lot of focus on trying to best progress towards globally the Aichi targets and focusing on using remote sensing together with in-situ observation. The big challenge we had in New South Wales was in regards to wetlands and wetland conservation is mapping wetlands. So this project is almost a surreptitious combination of my involvement that links back to ideas about mapping wetlands in new ways. And it came about because of the Global Freshwater Watch project, which is a collaborative project jointly between the Earthwatch Institute and the HSBC Bank, where the bank donates its volunteers 1 day a year to be a scientist to this global program, which covers 25 large cities across the world. In each city there's a separate research project. So I was approached to see if we had something in Sydney, and I thought, wetland mapping, can we do anything that relates to citizen science and relates to the Geobon work primarily the new work being done in trying to generate global land cover products for wetlands. So the questions we want to ask is, what can a volunteer, untrained volunteer, could do reliably with a smartphone or some kind of GPS, and how can these be used to refine remote sensing products, and how accurate are these products? So it's still going. The first stage is a preliminary protocol. We took volunteers out, and the next stage is refinement of protocol and testing, and finally, hopefully, good algorithms for using these observations to calibrate, validate global products. So we've been taking volunteers to wetlands, natural wetlands that show a lot of variation, and then wetlands over the last 2 years which have an increasing disturbance. And at the end of this, what we want to do is look at our data over 3 years, 3 collections a year at each wetland, made using app. We have a mobile phone app in which the volunteers go and just work out where's the edge of the wetted area, look at, take photos of the plant there, look at the edge of the wetland vegetation, and that these observations, while not being wetland delineations, feed into that process. The product at the moment we're looking at is the new global high-resolution land cover product for wetlands at 30-meter resolution, and developed by, again, within the GEO framework, the Land Cover Task Force, led by the China Geomatics Center. And at the end, what do we want to do? End up with a kind of front-end product where we might end up with thousands and thousands of observations that can feed into the calibration. There's already something along those veins in GeoWiki, you might have seen it, and it uses global land cover products and pixel validation by volunteers who can go in and say, this is right, this is wrong. And of course, currently it's very coarse. In that circle is one of the wetlands we're looking. The 1 kilometre grids don't help. But 30-metre resolution, and about 3 years' time, with European Space Agency will have 10-metre resolution global land cover. And there's promise that these products can generate globally automated, but ground truth products. It's food for thought. It might not work, but it's a new.
Yeah, I think it's a way of getting the biodiversity outcomes more to the global metrics and all the outcomes. Okay, Max, do you want to?
Thank you. If anyone's falling asleep at the moment, just turn around and look out that window over there. Those bright red seats are going to wake you up. So the speakers are at least are awake. What I want to talk to you about now, Australia is 65 wetlands of international importance under the Ramsar Convention. What does that really mean? Have we got the right sites, etc.? How do we know, etc.? And I think to sum up where this talk's going, we just have to listen to what the people have already said before me today. We need the type of information that you already have put forward to you. So we don't have a systematic approach, unlike what's been done in other ecosystems in Australia across the landscape. We do have a lot of information from various times and various parts of Australia. It's uneven, a lot of it's out of date, or you can't get your hands on it when you need it. I think a lot of people have those same sort of problems. But there have been attempts. But one of the issues we face in a country the size of this is the sampling effort. The sampling effort will help determine your biodiversity outcomes, or not, or bias them. We have a lot of trouble getting to a lot of our wetlands and really knowing what's there why they're important, and how they change in many parts of Australia from totally dry to totally wet, so large floods and large droughts, where the abiotic relationships change. And the cultural values, I've heard this before here, one point hasn't come out, the cultural values are not included. A lot of our wetlands have been bought because of the people who value the wetlands themselves. So their values, we have not got a process, at least that I know of bringing those values to the fore as we look at the biodiversity itself. So there are some methods underway. It's not as though people aren't trying. Again, the money is not going far enough or over a long enough time to actually look at the variation essentially we have. There are some new programs in place. The environmental flows program in the Murray-Darling Basin, which has worth a lot of money to Australia, investing in trying to fix the basin. That was just publicly signed off 2 days ago, I think. So that's actually starting. But I think we should have been there anyway. When we do have problems, our government agencies, officials, I used to be one of these people, we are defensive. If you write a letter to our agencies and say, look, there's a problem on this Ramsar site, they'll say, oh, but we're fixing it. Or we're spending money. You don't actually refer to the problem. Or come out and say, yes, it is stuffed. Almost said something else there, sorry. And especially ecosystem service analysis with these sites is lagging, if it's done at all. Under Ramsar, you should be looking at the biodiversity and the ecosystem services at the same time, not treating them as totally separate things. There are some positive trends, I said, out in the non-government area. But we have an issue, though, with some of our government agencies or agents of government have trouble accepting the input of non-government people. The government should be doing this. Who are you people doing it for? Well, because you're not doing it. But so you get to this art and you don't listen. There has been attempts in Australia for non-government groups to get Ramsar sites listed. I think Jamie might have got through. The one you and Kath did, I think. So there's been a lot of effort to try and, well, the government can't do it, so haven't got the funding. Well, let's get some money from other sources or different people, and it's very hard to actually get it through government process. But overall, this last issue here, I think, is the most important. 65 sites are not all inland, some on the coast. What do they actually mean? What do they represent in both the space, the actual land itself, the water itself, and the type of species that are there? I don't think we know. Until we do that, we cannot say we have a representative sample of our most important wetlands listed under Ramsar or any other instrument. That's just there. That just covers everything we've said before. Thank you.
The last of these cases, which is or methods, really, strongly speaking.
All right, thanks, Ian. My name is Harmony Patricia. I'm with the Australian Rivers Institute at Griffith University. And for the past 5 years, I've been fortunate enough to work in the Mekong River on fish conservation and research. And about 1.5 years ago, I started my PhD at the Australian Rivers Institute, and I've been applying these environmental DNA methods to identify critical habitat for rare species. So I think one of the biggest challenges with identifying priority locations for effective conservation is that we just don't have the distribution data that we need, especially for rare species. It's extremely difficult with conventional methods to collect presence-absence data for rare species or in highly biodiverse systems where taxonomy requires really advanced expertise or there's high biomass of fish or the fish are widely dispersed. And these are the systems that are really in need of effective conservation. actions. So I think, you know, these conventional methods, while they can be useful, they're not really getting us to the places we need for the species that need the conservation actions the most. And so when I started my PhD, of course, I did the literature review, and I found this cool technique called environmental DNA. Basically, it relies on the fact that all organisms shed their DNA into the environment. In aquatic systems, usually these molecules last for about 1 to 2 weeks. So you can literally take a water sample and extract the DNA from that water sample and see what species have been recently present in that location. It's become much more affordable in the past few years with development of this new next generation sequencing technology, which allows you to get 20 million, 100 million sequences for, you know, maybe $1,000. Basically, it can give you rapid biodiversity data for presence, absence in different locations, and there's quite a bit of work showing that it's more accurate, less invasive, and less expensive than conventional methods. So I applied the method in the Mekong River, the lower portion of the Mekong River, which has many of the challenging conditions that I described before: high species diversity, long distance migrations, fish that are highly threatened and dispersed across large areas, and currently we just don't have distribution data for a lot of these threatened species at a scale that would be useful for systematic conservation planning. So I took water samples in 8 locations throughout the river in Cambodia, Laos, and Thailand, primarily in these deep pools that are known to be important refugia habitat for some highly threatened species like the Mekong giant catfish. Basically, you filter the water sample in the field, which traps the DNA in the filter, take the filter back to the lab, extract the DNA using methods that are based on ancient DNA techniques, so you can detect very small fragments of DNA in very low quantities. And my portion of the work is using primers that are designed just to amplify certain species, like these very rare giant catfish. And I'm also collaborating with a company in France called SpyGen that specializes in environmental DNA, and they're doing next generation sequencing and using universal primers that will amplify a bunch of different species of fish. And fortunately, we were lucky that we detected the giant catfish in 2 out of the 8 sampling locations. And when you consider that this fish is thought to be distributed over 1,500 kilometers of river length, and our best estimate is that there's less than 200 spawning adults left in the whole system, it's pretty good that we were able to detect it at all. SpyGen is working out their results now, but they tell me that they detected quite a large number of other fish species with the universal primers. So basically this can help us identify, you know, which areas have higher species diversity, which areas are being used more often for these highly threatened species, and then we can prioritize those areas for protection in FPAs or fish conservation zones. So I just want to acknowledge all the support from other people involved in this project. I'm going to continue to work on this. I'll be going back to the Mekong in a few months to do more extensive field sampling, and hopefully I'll get a couple publications out soon. Thank you.
Okay, great. So that covers a few examples, I think, of how we're looking at protected area prioritization and how we can continue to use new techniques in the future.